Hey everyone, thanks for having me here. So I'm here to tell you about FHIR and the relationship between FHIR and OMOP. Someone said to me over lunch, are they competing with each other?
Yeah, which one's better?
Huh?
Which one's better?
Yeah, well, no, they're not. And I'm talking to you about data acquisition, but a bit more as well. So first of all, I have to give you some context, and then we'll get to the subject. It's about me. I have a very long and varied history. I grew up as a farmer in New Zealand, and I thought that's what I was going to be doing. It didn't play out that way, but I did 6 years of clinical research, so I know a little bit about this. And then I ended up as a CTO at a vendor, and then I created FHIR because I believed that we really needed a better way to exchange data. And I do that through HL7, which is an international standards organization that is pretty well known around the world for writing healthcare data standards for exchange between healthcare applications to support the healthcare process. So I'm going to come back to that sentence a little bit. So I started working on FHIR because I could see that healthcare was full of broken processes. So what I typically see when I travel the world is that everybody who's providing health, almost everybody, takes that extremely seriously and focuses on providing world-class healthcare for the bit that they do. And the important part of that sentence is the bit that they do, right? Because everybody's little bit is close to world-class or is world-class, but the experience as a whole for the patients is not world-class. Although in some ways everybody's in a mess, so it is world-class, the mess. But it's not, it's the gaps between the bits where the challenges are. And so in that sense, health has broken processes, the process as a whole. Other industries were being transformed, are being transformed, and the IT support for those industries enabled the transforms. But the process is not happening in healthcare. And one of the reasons that was because IT was a mess. The standards didn't support an integrated approach between business to business back-end exchange in hospitals and between hospitals and governments and between hospitals and GPs and with the patient and the providers. It's all a mess. Institutions keep records for institutional purposes. They don't keep them for the benefit of the patient, nor do they keep them for the benefit of the care provider. And while the real problems are cultural, procedural, educational, regulatory, and those are the hard problems to fix, there's no point trying to fix them if IT's in the way. So I set out to move IT out of the way. I thought I'll take credit for the easy problem, right? Those are the problems, are the hard problems. And so I created what became FHIR. So FHIR is, for me, is the web for healthcare, and it's two parts, and Patrick kind of got this really good before, that for me, it's the community, and then the community produces a technical specification. But the real value, the important part, is the community. A community of people who are focused on solving the problems of moving data in healthcare to support the care process, make it easier to exchange healthcare information. We are open community, like Odyssey, anybody can be a member. You just have to give us your time. Of course, your time is the most valuable thing of all, right? But that's all you have to give us. You don't need to pay money to enter or whatever. And we're led by HL7 and deeply connected to healthcare around the world. And then the way it works, like Odyssey, is we argue and we argue some more and we argue some more, and then we actually come to a compromise and we write that up and call that the technical specification, the standard, which explains how to exchange healthcare information, and we publish it as a public domain specification at a known address. It's a web API. And one of the features that it has deep continuity with existing content, because anybody could imagine a cleaner, better healthcare system if we just started by sweeping everything that we have right off the table and started again. including our legacy records, our legacy patients, our legacy employees. Perhaps this is not really a very good idea. We have to work with what we have. And so in some ways, FHIR is compromised by the need to work with what we have, but because we work with what we have, healthcare systems around the world are saying, this is the future, this is where we're going, it's a compromise that we all know how to get to. I mean, I could certainly, there's bits of FHIR that could go, we could imagine something way better, but we wouldn't know how to get there. And it's really important that it's freely available. So the known address, there's no license restrictions. We use Creative Commons 0 because everybody derives from the standard, much more so, I think, than with OMOP and Odyssey. Everyone derives, publishes code, publishes other specifications. There's this whole ecosystem of stuff cascading off that if we put any license restrictions on, that would pop up somewhere in the community as a bomb for somebody. But no, it doesn't. Everything's free, and actually the community has jumped on board, and even lots of the commercial providers doing commercial projects have just said, we're just gonna make all the specs open source. And for me, this is a huge part of our value proposition, that we love commercial companies because we like being paid for what we do. I do get paid for what I do, and I hope you all do as well, at least when you stop being students. And that means commercial basis for work. So for me, open source is not about stopping commercial companies making money, but it is about stopping commercial companies making money by camping on a space instead of providing a service, right? You want to make money, you better provide a service for that, not just claim that you own something that someone else can't have and so you can make as much money as you like for nothing. And one part of this, I don't know how many of you appreciate this, but open source is the worst thing that you can get. They're probably looking at me going, you're an idiot. And that's what I thought when the first person told me that. And I'm not looking at him going, you're an idiot. And he said, you're thinking I'm an idiot. But think about this. Imagine that there's an open source project and you're a company selling software that's not as good as the open source software. You're doomed, right? You might be able to hold on by camping on the spot, but you're gone. And so open source is the worst thing you can get. Sometimes it's also the best, but it's always the worst because you can't sell something worse. So as we write open source, we're actually lifting the floor, right? And forcing companies to keep ahead of us. For me, that's the real function of open source software. And yeah, sure, sell FHIR-based software, sell OMOP-based software, but you have to be better than us, right? Service. So that, for me, that's the open source philosophy. And that was a huge part of what FHIR is and a huge part of what's driving the entire ecosystem towards FHIR. So what it actually is a healthcare API. A list of operations that you can perform on a software endpoint that correspond to real-world healthcare operations. Some examples here like, we'll watch this patient's details, fetch a laboratory report, prescribe a medication to the patient, which will actually lead to a physical person or a machine sometimes actually generating a prescription which the patient will then pick up, or suggest a treatment option for a patient based on diagnostic reports, and so forth. And then, so basically a web API with a lot of operations that map through to real world operations with defined content, which is where we come to the relationship between FHIR and OMOP, because defined common data model, right? So that's what we do. So just have a quick look at how that works. So all the operations that we define, all of them work by exchanging our basic unit of operation, which is a resource. And a resource, there's lots of types of resources. They cover things like meta-knowledge about what's going on, and patient administration and workflow and billing, and then the clinical record itself, and then clinical reasoning and care planning and reporting on health outcomes from the healthcare system. And sometimes I think that my primary problem is what is not healthcare? Because they came to us and said, well, you're nearly there, so can we do banking? Because healthcare does banking. And I'm like, no, we're not doing banking. And so far, that's pretty much the only thing we've said no to. Because everything else is healthcare. Okay, so then we just describe different kinds of operations on these base units of operation that carry a set of data that everybody agrees to as the basic set of data that we all have for these things. And then people crop up and say, oh yeah, but in Australia, we've got this weird thing called Indigenous status. We're never going to add that to the international standard because every country's got its own crazy view about Indigenous and ethnicity. And so we can extend the standard in different countries by different universities, different institutions, by defining our own extensions to the data. And we have a common declaring framework so that everybody can see each other's extensions and work with them. So my favorite example, in Tanzania, you can't address a letter without a special addressing postal district number that nobody else has. So in Tanzania, we defined an extension for postal district, and then the software knows that it just picks up postal district and makes a box for it in the user interface. It's all sort of self-declaring. Now, there's some odd features about our resources to most people. So here's the patient resource, our basic record for describing a patient. And so beyond having a multi-year argument about whether we could use the word patient or consumer or something else, which we eventually stuck to patient, I wanted to point out to you that that patient has some contacts, their relatives, and some information about their human communication language, and links between patient records, because when patient records are merged and unmerged, which you really don't want to deal with in an OMOP database. But we really don't want to deal with that, but we don't have any choice, right? Because operational healthcare, 1 to 2% of the records are duplicates, 1 to 2% of the fixes to duplicate records are erroneous. That's always been the number the entire time I've been in healthcare. And these are the kind of things that you don't want to have in your analytical database. You need to eliminate those things, but you have no choice but to engage with them for operational healthcare. Another example, see on the top left there, we have multiple names and multiple addresses and multiple contact details. It's very rare to see a research database, an analytical database, where you have more than one name for a patient. Mostly you don't have a name for a patient because it's de-identified, but not always. But in operational healthcare, you need to worry about patients' multiple names. Their legal name, their actual working name, their nickname, their maiden name, their old name, their name that you can no longer use because someone else with that name passed away. There's a long list of names that people have. And you can't afford to ignore those in the clinical record. Same for addresses, past addresses, so you can make sure you can identify the right patient properly. And again, these things you don't want in a research and an analytical database. And I'm laboring this point because it gets worse, because there we go, look at like an address, it wants the bits of an address or an identifier. These are general purpose models that are used across the world for all sorts of different things and are the super complicated unison of all the use cases that we found around the world. So for instance, we had a huge argument. You'll see family there is a family string 0 to 1. One family name for a patient. Calling it family has got own complications for Iceland and for Ethiopia, for instance, but we decided that we would. And also, maybe it needed to be 2 parts for all the Spanish cultures. Big, long debate with the Spanish cultures about whether it was going to be 1 or 2. We settled on 1. But these things are somewhat compromises to drive the clinical system. So what I'm laboring this point, which I don't usually, is because we are doing something different in our common data model to what the OMOP common data model is doing, right? But if you are in the habit, as you all are, of extracting data from operational healthcare systems in order to do analysis. These are things you have to deal with one way or another. Okay. So as I've said, the operations are focused on supporting operational healthcare, and we're obsessed with context and precision and fidelity to the process. We're very fine-grained information. The resources are deeply nested because, you know, some use case somewhere says that there might be more than one of these things or whatever. And we're very concerned with support for workflow and fidelity around, is this value current? Is it changing? Is it changed? You don't do that stuff in our analytical database. But we do cover also reporting in some of our data, reporting measures, population aggregate statistical reporting. And there, you're not so concerned with precision or with context. You flatten that stuff out and you start thinking about accuracy and aggregation issues. And we do have resources that are related to population aggregate data, and suddenly we're in the OMOP space. So I'll come back to that. All right. So the other thing is that FHIR is an API specification, right? For us, the application is a black box. This is how it behaves. We don't really care what you put inside the black box. It could be a relational database, or you could write everything to flat files, or you could use a documents. We don't care what you do behind it's your business. You just have to meet the API. But some users have said, you know, the FHIR model, it's really nice because it's everything that we'll ever run into. And so it's going to be our lingua franca internally in our system. The API is our model, and we'll just store resources as they are. And that's not a tremendously efficient thing compared to a really well-indexed data model, but really well-indexed data models have their own cost. And the tools around RESTful APIs getting pretty good. And in fact, there are a number of countries running entire country operational healthcare systems on a single FHIR database where the FHIR resources are what they're storing. They're running countrywide clinical systems. So it is happening. I don't particularly recommend doing that because you need to engineer what you're doing. But people are doing that. It's not wrong. We just design for the API. Now, there's one more thing I need to say about FHIR. FHIR is not a silver bullet in that what we put in a FHIR specification for the entire world is what the entire world agrees to. I don't need to tell you guys that's not very much, right? USA, you must report race and ethnicity in the US race and ethnicity framework, which is even crazier than ours. In Australia, you must do it our way. In China, there's a different set of concerns and so forth. Every country's got its own craziness. And the basic principle is the bigger the community, the less you can agree to. But as you get a smaller community, you get more things in common. A common language, a common set of rules and laws, a common boss when you get to a small enough. And so the smaller the community, the more you can agree on. And so we have a cascading set of agreements that people build on top of. We've got Australian agreements, we've got Australian prescribing agreements, we've got the Chilean prescribing system, so forth, right? And each of them branches off with their own set of agreements. And we publish those sets of agreements in things we call implementation guides. And smaller communities have more in common. Okay. So there are 3 touch points between FHIR and OMOP. One is around the terminology layer, the vocabulary management, the concept table. Another is that it's a pretty common thing and will become more common to take FHIR data, operational healthcare data, that will be how you get that, and convert it to your analytical data, and then around quality measure evaluation. So we'll just go quickly through each of those. In the terminology layer, OMOP has concept tables, and there's a bunch of tables that either directly hang off concept or are related to the concept tables. And they define the concept IDs with mappings to the external terminologies, synonyms, relationships, and domains. Those are the important ones. And those are really important and really valuable, and from where I sit, a really interesting value to the much wider community than just the OMOP community. And so we have concepts for those things in FHIR, which are like one-to-one maps, almost, and we call them code system, value set, and concept map. And so I think we're still discussing this between our communities, but I think these equate to one code system, a set of value sets, and a set of concept maps for the relationship table and the mapping to external IDs. I'll just quickly show you. Here's a draft code system that I wrote last week for the group that are working on this. So it has a URL fhir.odyssey.org/codesystem/concepts. That's a FHIR structured URL, but it's in the Odyssey space. And then a thing about what properties concepts have, and then you can see 381591 is the concept ID, and then it's in the condition domain. And so that's a tiny fragment of the concept ID table. And what we need to do is agree on, so that we can use this outside OMOP, we need to agree on the property names and the URLs, and they're under the authority of Odyssey, and that's a joint process that we're working on, and it's not fully resolved yet. And then there's a value set where we say, well, all the concepts with a domain of 19 are in the value set condition, all the condition concept IDs. And then there's the important ones, the maps. So this is a concept map that says we're going to go from condition to SNOMED CT. In the space of the condition value set and all of SNOMED, here's a map from the concept table to SNOMED. We map from 381591 to the SNOMED code 629 blah, blah, blah. SNOMED codes are always 629 blah, blah, blah. And this is just generated straight out of the concept table. For each of the relevant entries, they go into one concept map or another. And then this is like not particularly compelling to the OMOP community because you've already got the tables. But the really good thing for us is, and for people bringing data into OMOP from FHIR or from elsewhere, is that now we can provide you with the services through the standard FHIR terminology services that more and more software around the world is using. Given an external code, get a concept ID. Given a concept ID, get an external code. Or we can leverage the relationship table outside OMOP. Give me a cross map between ICD-10 and SNOMED. There's quite a few users outside OMOP who would think that's a pretty nice thing to have. And in fact, it's very likely to get quite a bit of use. So that might actually be problematic for the OMOP community, because you'll suddenly get a whole lot of people using that table, putting a whole lot of attention to it, and probably using it in ways you didn't expect them to use it, and criticizing the table, both for good and bad reasons. That will happen. Okay. But for me, that's really useful because it's support for the next bit I'm going to talk about, which is FHIR to OMOP. So you get data in FHIR, and this will become increasingly common. It is not particularly common in Australia right now, but it is particularly common in USA, which are the kind of the furthest down this road. But for instance, the Australian government loves paying for data to be moved around inside silos. We have paid far more money to move data around because we do it inside silos. It would have been much cheaper to have just said, no, we're going to just do it once. And they finally got the message. And the Department of Health, who have paid again and again and again for data to be moved out of GP systems and otherwise, are in the process of getting ready to go to the GP vendors and others and say, there is only going to be one export format, FHIR, at bulk. And so you will start getting more and more of this, as is already happening in other countries. So it's a good intermediary source for your data anyway, because everybody or lots of other people will like to have it in FHIR format. But let's say it's not necessary to use OMOP to do the analysis. You have people in the FHIR community who are doing pure FHIR analysis. They build a massive data lake. The biggest I've heard is 100 billion records. And then they figure out what question they're going to ask of the data. They do what they call a projection, and they rip a whole bunch of data out, simplifying it as they go. And I explain why simplification is a big deal. And then they do the analysis. Don't need OMOP. And then they publish their results. So where does OMOP come in the picture? It, of course, misses the benefits of OMOP. The people who do that, they're tooled up to the max. They don't need SQL. They're coders. They've got lots of tools. Google, for instance, man, they've got a lot of tools internally. So it misses the benefits of OMOP. And so it's useful to take the data from FHIR that you get, the operational data, and convert it to OMOP. So that's a lossy transform. You lose all that context and precision and fidelity out of the FHIR data, but everybody's doing that in order to do analysis. That is a value proposition. It's not a problem. It just means that it's not right to think that you could go back. That's not something you do. You take your data, you figure out how you're going to simplify it, and then you do your analysis on it. And so you simplify it into OMOP, and that's interoperable. That's a feature, right? That's good. That's why you're here. I don't need to tell you that. But there is a risk. See, in the FHIR space, when we convert data to FHIR, when we do the analysis in FHIR, we say, what is the question? How do we simplify the data for this question so as not to introduce systemic bias? But in the OMOP space, you do one conversion and then ask questions of the data. So there's a risk that the assumptions and simplifications you made will introduce systemic bias for some questions. For me, you guys aren't paying quite enough attention to that risk. And I would suggest that it could be something you pay more tools to. And I'm way behind. So we also have a project going where we are operationalizing in the States clinical measure evaluation, so that the government issues a bunch of measures which are really phenotype stratification approaches, and they want to know how many patients fit into each of these. Have you done something? What's the outcomes? Whatever. And then you get a set of results back, which are phenotype outcomes in OMOP language, and you do not need to. We don't care how you analyze that, right? You can do it on your FHIR data, or you can do it in your database directly, or you could do it on OMOP database, and people are doing that in the States and working that up as an approach. So that the clinical system has an OMOP database, and whenever they get these measure reports to do, they just run that out of the clinical database. And I've run out of time. There's a lovely big diagram that someone presented to us last year about how they're doing that. We have a bunch of work that we're doing together to operationalize some of this stuff. In particular, a whole sub-community at HL7 is focused on how to use FHIR and OMOP, and Vulcan is around clinical research. One more thing. I meant to change the slide, but FHIR sets out to be disruptive and to improve the way healthcare is done. And I have a really common feeling here with OMOP, they're setting out to do the same. And so thank you for doing that. I appreciate it very greatly. Thanks.